There are two things that I'd like to talk about in this question. We're asked to find the resultant, vector r, given vectors 1, 2, and 3. We can add any number of vectors using their components, so it doesn't matter whether we have 2 vectors, 3 vectors, or 16 vectors. The other difference in this problem is that we're asked to add vectors 1 and 2 but subtract a third vector. So let's see how that happens. As always, let's start with a picture. Vector 1 at 28 yards is directed at 289 degrees. So it's actually sitting in quadrant 4. Vector 2 at 49 yards, clearly forgotten the units here, is directed at 237 degrees. So let's say roughly there. And vector 3 is 31 yards long and directed at 383 degrees. So vector 3, oddly given at greater than 360 degrees, would be in quadrant 1 and intermediate in length between vectors 1 and 2. However, we're being asked to subtract vector 3. So I'm going to mark that right here. I'm going to subtract vector 3, which also means I'm going to draw, instead of positive vector 3, I'm more interested in negative vector 3. Negative vector 3 has exactly the same magnitude, but is turned 180 degrees in the opposite direction. So we could either draw it as looking like that, or to draw it on the coordinate plane, we'll pick up this vector and draw it as starting at the origin. I'll go right ahead and label negative vector 3 in the diagram. We're adding now because we've already drawn negative vector 3. So we'll add vector 1, vector 2, and negative vector 3. Okay, because we've got 3 vectors, why don't we just go ahead and use the polygon method? And start with any of the vectors, but why not start with vector 1? That means I'll draw vector 2 where vector 1 ends, and then finally negative vector 3, well, I'll draw that where vector 2 ends. So negative vector 3 is over here. So it looks like our resultant vector will be in quadrant 3. Sometimes we're going to be wrong with this. It is just a sketch, but I'm pretty confident that vector 3 is going to be in quadrants 3 or 4, certainly not going up along the positive y-axis. I can tell that because all of the vectors 1, 2, and negative 3 have negative y components. So we can guess that the resultant vector will look like this. And I'll label this as the resultant, VR. All right, let's look for those x and y components. So I've started by writing down how I'll calculate the x and y components for vectors 1 and vector 2. And then I'm going to go ahead and just calculate the x and y components for negative vector 3. In other words, rather than simply taking 31 and multiplying it by the cosine of 383, I'll use negative 31. Similarly, to find the y component, I'll use negative 31 and multiply that by the sine of 383. Because I've already taken the negative into consideration, I'm now going to add the 3x components. So I'll take 28 cos 289, I'll add 49 cosine 237, and add negative 31 cos 383. You can do this again by evaluating each expression separately and then doing the addition, or by adding the 3 expressions in one go. Either way, to 3 decimal places, we'll get negative 46.107 for the x component of the resultant, and negative 79.682 for the y component of the resultant. Which quadrant is our resultant in? Well, because its x component is negative, as is its y component, we can confirm that it is in fact in quadrant 3. So now that we know the components, we finish the question off the same way we have the previous ones. We find the magnitude of the resultant using Pythagorean theorem, and then we'll find its direction using inverse tangent, being aware that our resultant is in quadrant 3. So here, we do need to be careful when we're using the Pythagorean theorem that we take negative 46.107 and square the whole thing. Again, if you just use positive 46.107 and square it, you'll get the same result. Because positive times positive is positive, and negative times negative is similarly positive. And then we'll add 79.682. Sorry, that's negative 79.682. Let me be exact here. Throwing that into my calculator gives me 92.06. And rounded to the nearest whole number, which is how the question is presented, is 92 yards. What about theta? Well, we'll use the inverse tangent, and this time let's use the absolute value bars. So tangent is y over x, so I'll put negative 79.682 over negative 46.107. And here, negative divided by negative is positive anyway, so the absolute value bars were unnecessary, but it's good to have those in there. So taking the inverse tangent of this ratio, we get an angle of 59.94 degrees. Where's 59.94 degrees on our diagram? Well, that's going to be the reference angle, in this case down from the negative x-axis. So to find the angle in standard position, we have to take 180 degrees and add 59.94. So to find the angle, it turns out this is not the resultant, this is just the reference angle, so we should amend this here. To find the angle of the resultant, we'll take 180 degrees, add 59.94 degrees, and round it to the nearest whole number. This gives us 240 degrees. So let's summarize that one last time. We have the resultant vector with a magnitude of 92 yards directed at 240 degrees.